Next, we are going to talk about electrophilic substitution on the benzene ring in phenol. So the hydroxyl group is activating because it is electron donating, which increases the electron density on the benzene ring, and it is also 2,4 directing. And because of this, it makes phenols much more reactive than benzene towards electrophilic substitution. And the two examples that you must know which illustrate this are nitration and halogenation. So we're going to look at nitration first. When you react phenol with dilute nitric acid, you will produce a mixture of 2 nitrophenol and 4 nitrophenol. So even dilute nitric acid is sufficient to nitrate phenol, whereas if you want to nitrate benzene, even for mononitration, you will need a mixture of concentrated sulfuric acid with concentrated nitric acid with heat. So if you use concentrated nitric acid instead, it will induce a polysubstitution, and there will be 3 nitro groups in the compound to form trinitrophenol, 2,4,6-trinitrophenol, which is explosive. Next, the halogenation of phenol. So if you react phenol with aqueous bromine, the bromination occurs even without a Lewis acid catalyst to form 2,4,6-tribromophenol. But if you use an organic solvent such as CCl4 instead, there will only be a mono substitution, so a mixture of 2 and 4 bromophenol will form. And recall, in order to halogenate benzene, we need to react the bromine, liquid bromine with benzene in the presence of a suitable catalyst such as iron 3 bromide. So again, this illustrates that phenol is much more reactive towards electrophilic substitution compared to benzene. And finally, this reaction of phenol with aqueous bromine can be used as a test to identify phenol, but not just phenol, but highly activated benzene rings in general. So the other example that you will encounter a few chapters from now is called phenolamin, which is C6H5NH2, because the NH2 group is even more strongly activating than the OH group. So the test is to add aqueous bromine to the compound, and if phenol or phenolamin is present, the aqueous bromine will decolorize and a white precipitate is formed. So for example, if it's phenol reacting with aqueous bromine, we're going to get 2,4,6-tribromophenol, which is an insoluble white solid. That's why it appears as a white precipitate.